Alrighty. Talk briefly here about the tests and the retake process. I sent an email out last night. I hate to take class time. It means you're going to have to watch more of a lesson to go over a test, but we're just going to have to do that. So next week, Monday and Tuesday, I'll be going over the tests with the classes, and we'll talk about the retakes then, because the retake process has to change this year given that there are distance learners that are involved too. So I need a day tomorrow to figure out exactly what I'm going to do and how to get that accessible to absolutely everybody. In the meantime, you have to have all your homework in to be eligible. That's not a problem for most people. The other things that I saw just briefly, it does appear, unfortunately, that some people are not watching and listening to the videos. And I know that because the mistakes that you're making are things that I said multiple times on the video, and that's really not possible if you had listened to everything. And some people might not be doing the homework. There were some really, really good scores. That's what I want to focus on, 50 and 49 out of 50. But you got to listen along with writing down everything that's in there. And you have to do the homework yourself. I know the worked out solutions, especially, I know you guys have a lot to take care of this year. You got to watch a lesson and you have to do all that. But please remember, this class pays for itself with those 5 college credits. So you are working, and that work has to be done in advance. Now, after saying that, the things that I said about, listening, those would have been minor things. They would have been like 1/4 of a point off or 1/2 a point off. There were the bigger things that told me some part of this people are not doing, because not knowing whether or not a triangle is isosceles, not knowing what it takes to make it isosceles, not knowing the basic equation for a circle, those types of things, those are concerning. So we've got work to do, got to push it. Today, grab that yellow little lesson objective packet. And we're going to see, for something that's going to take, almost 2 days, I think it's like a day and a half for P-5, there's only 3 little things in here. And so, we have to solve equations graphically. Yeah, that's only after we do the algebra. Everything at the pre-calculus level, we do elegant and perfect, which means we're going to use the graphing calculator to double check. And then I can solve equations algebraically. Absolutely. That's the key. Show all the steps. Points come from steps. And I can solve equations numerically using tables. That one, we don't use tables a whole lot. I'm going to show you how to get to the tables and do what you need to do, but there are more efficient ways with the graphing calculator to find things, and we want to learn those more efficient ways. So you can rate yourself before the lesson on those. You might feel a little rusty, but after today, first hour was like, oh yeah, now I remember how to get in here. This is all good. So graphically, numerically, and algebraically, we're going to be able to use trace, find the intercepts, which are the zeros, and find the intersections on the graphing calculator. And solve equations algebraically. Linear ones we've already done in the other prerequisites, and that was on your first test. We want to talk a little bit more about the quadratic ones today, and maybe some strange ones. We're going to get a little bit into the factoring, the extracting the roots, completing the square, and the quadratic formula. Those are the 4 ways that we have to solve a quadratic. And then solve equations numerically using tables. So, lots to start on today. Well, graphing calculators, we're going to use them quite a bit this year because we want to demonstrate things. We want to see things. We want to eventually be able to see an equation and have a picture in our head of what it looks like. And the way that you do that best is by using the graphing calculator to see, what are these? What do these look like? Emphasis is on the algebra behind every problem. And so as we start the completing the square process, we're going to learn that those little intricacies of algebra are really important, whether or not you're doing pre-calculus or calculus and beyond. Feel free to verify your solutions with the calculator. Don't rely on it. In fact, you are not allowed to use the calculator on the AP exams in calculus. You can't do that. So we have to kind of pull back further and further It's for demonstrations, for solving to double check our answers, and always try to picture what the graph should look like before you grab a calculator. We should be developing our mathematical common sense. So, I look at an equation and I see x to the first, and that's the highest power of the variable. I realize that's linear. So in my mind, if it's a positive number in front, I'm getting that little picture in my head, you know, of a positive slope that would take place with a line. Then, if I see something negative in front, I would think of it as a downward slope. Then I see the highest degree of my x's, my variable is squared, and that I know is a quadratic. So I start to think, okay, quadratics. If there's a positive number in front of an x squared, that means it's an up opening parabola. If there's a negative in front, that means it's down opening. So this is your basic up opening parabola right there. Then I get to third degree polynomials, which are the cubics. I start thinking, what do I know about cubics? Oh yeah, they're the crazy S-curve. Looks kind of like a snake. And if it's a positive in front, it does this kind of thing. You know, a little bit of curvy business going on. Now, there might be some lumpy bumps in the middle called turning points. But those are not determined by the highest degree that you have inside your polynomial. If there's an x squared, an x, and a constant in the back, that's what determines what happens in the middle. So what I'm showing up here are just end behaviors. The end behaviors would be the same. Then I get to x to the fourth, which is a quartic. And if that's the highest power of my variable, I start thinking, well, wait a second. All even degree polynomials have the same end behavior. So if there's a positive in front of the x to the fourth, it's going to be an up opening parabola. If there's a negative in front, it's going to be a down opening for just the end behavior. Again, what happens in between turning points come from all of the other math that's behind it. You know, x to the fourth plus 3x cubed minus 2x squared plus 8x minus 7. There's a lot of stuff going on. So that would give me some turning points in the middle. Even degrees, they act parabolic. Odd degrees act like our cubics, our S-curves, when we go through that. So when we see an equation, we want to start thinking, what does this look like? So that when I punch it into the calculator, I'm going to know if my big fingers hit something they weren't supposed to. You know, I'll know that by what I see. So, solving equations graphically. To solve an equation such as 2x minus 5 equals 0, this is so silly, you can graph y equals 2x minus 5 and find where y equals 0. Nobody in their right mind would do that, especially on a test where you get points for showing your work. We would just add 5 and divide by 2. But this is a really great demonstration problem for stuff on the graphing calculator, so that's why this is here. So what we would want to find is where y equals 0, and you can see from the picture that's right here in this blue dot. And if we want to find that, what we're really finding is the x-intercept. Where does it cross the x-axis? That's what we're finding. Now, all the directions that we see here for graphing calculators in our book or in our notes are more generic than saying use your TI-84 Plus. It says use a grapher. And that's because if you're at home and you don't know where your graphing calculator is, you could always go on the internet and find one of those free graphing apps and use that. So the instructions will say things like use the 0 feature or the intercept feature on the calculator. Well, our calculator is probably not going to have intercept on there, but it will have 0. So, away we go. We want to verify that it says verified algebraically. We're actually doing this backwards. We should do algebra first and then verify graphically. So, let's grab the graphing calculator. And I'll go back to the main screen where you guys would be. We want to graph 2x minus 5. So we're going to go into y equals, and we're going to do a lot with this, so please follow along as we go through all this. And we need 2x, and x is just to the right of the green alpha key, and -5. Enter. And now the first thing I want to do is remind you, most things that we do will fit inside that nice -10 to 10 window, and that can be found under Zoom 6. So if we want that -10 to 10 window, we can just hit Zoom and 6, and it'll automatically give us that -10 to 10 window. So there it is. And if we had graphed this, we would have said, well, we have to go down 5 because that's my B value, and then up 2 and over 1 to get the slope. And yeah, this is not shocking at all. This is what we should see. But what I want to know is that at 5/2? Is that at 2.5? Well, there's good news. First off, we get to play with Blinky. Blinky is my pet cursor. My pet cursor is hypoallergenic. No one will ever be allergic to Blinky, and Blinky has had a lot of months off, so Blinky he's ready to go. He's excited. And to find Blinky, we have to figure out, where does the calculator tell us this stuff? And it always tells us this stuff under second trace, because in the blue we see CALC, which is calculate. Now, Blinky, what I need you to tell me is number 2, the zeros. So you can either hit 2 or you can scroll down and hit enter. And now there's Blinky. Hi, Blinky. Long summer off. So Blinky is going to ask me some questions so that he can figure out what exactly it is I'm doing. And the first thing he says is this the left side of this? Well, yeah, you're pretty far away, though. Let me move you over there with my right arrow key. That's a little closer. That'll help Blinky out a little bit. And then I hit enter. And then Blinky says, hey, is this the right side of all of this? Well, no, because this is to the left of the intersection. I need it to be to the right, so I'm going to hit my right arrow. Now I'm to the right of the intersection, and I hit enter. Some of the newer calculators that you have will actually give you these little lines right here, but most of them don't. Most of them, it just says right and left. And then I love this about Blinky. See how playful Blinky is? He's asking me if I want to take a guess. No, Blinky, I want you to do this for me. Enter. There it is. Blinky says, you are right. 5/2 is 2.50. There it is. We have it. Now, if you look inside your notes, you'll see that they didn't use a -10 to 10 window. They changed it. Well, that's probably a good idea too. You know, we can do that. So let's do window to remind us how to do all this changing. And they had it go from -4.7 to 4.7 for the x's. So the first box is the x's. Make sure you use the negative button and not the subtraction symbol, or your calculator's going to yell at you. And we can definitely go by ones. Ones are fine. And then for the y's, it said something goofy, -10 to 5. And again, our y scale, we can just go by ones. Now, I want it to graph that just as it is. I don't want it to go back to the -10 to 10, so I'm just going to hit graph. And there it is. It's just a little different look. And I think it's tomorrow's lesson where you have to do that, because sometimes things don't show up if you don't mess with your window and change it a little bit. Now, another feature they want us to remember is here is the table feature. That's under second graph. So I'm looking around because I want to know, when is y equal to 0? That's where it should be crossing, and I realize, uh-oh, it'd be right between these two, the 2 and the 3. And I know it's at 2.5, so I kind of want to see that in my table. So what I have to do is change my table settings. And that's going to be in the blue right above window, so second window. It can start at 0, but I'd really like to see it go by 1/2. So I'm going to put, this little symbol is delta. It looks like a triangle. It means change. So I'm going to change the table so that it goes by 0.5s. And we don't need to mess with the independent and dependent stuff right now. That's fine as it is. So now if I hit second graph again, now my table goes by 1/2 for each one of those. And I can see, yep, my 2.50 Perfect. Normally I don't want my table like that, so I'm going to go back and set my table to just go by ones again. So another feature that allows us to switch things so that we can see what it is that we want to see. And let me get that out of there. So this first one is really reminding us big time about some of the features that the calculator can use as we go through here. But again, algebra first, then graphing calculator. So we talked about the zero feature. On our calculators, it's going to be the zero feature. Can't guarantee that on the Inspire. They might use the word intercept because it's a little bit fancier. And we verified this with our graphing calculator. We changed the window, we changed the table, we did so much. And this one will be a little more interesting. So, solving by finding the x-intercepts. We want to solve the equation 2x squared minus 3x minus 2 equals 0 graphically. First thing we would always do on a test is solve it algebraically. So, we look at this and say, this is a quadratic. The first way you try to solve quadratics is by factoring. So let's see. Can't pull a 2 out of everything. That's not a perfect square trinomial. Pretty obviously, I'm going to need a 2x and an x. In the back, they have to multiply to negative 2 and somehow give me outside times outside plus inside times inside of negative 3. So if I put negative 2 here and plus 1 here, that'll be negative 4 plus 1. Hey, it's factorable. Cool. Because then I can find the zeros algebraically. And that is absolutely what we do first for everything. We try and factor with our quadratics and see if we can find it. So, what I want to do is think, what did they have me do? Well, if it was just solutions, this is fine. I can leave those answers. X equals negative 1/2 and x equals 2. But if it asks for the zeros, I need to tell them that they are at negative 1/2, 0, and 2, 0. And giving those in order from the number line perspective is really important at this level. So the negative 1/2, 0 first, and then the 2, 0. So here, and I can't even see those little blue things, so I'm going to go about there. And I think, well, it has a 2 in the front, so it's going to open up. Going to be a little skinnier than x squared because that 2 in front vertically stretches it. I think it's going to look something like that. Which brings me to the, hey, I need to know how far this thing goes down. And we do know for quadratics how to find that point for parabolas. And it goes back to a little formula you learned way back in exponential algebra, and it was x equals negative b over 2a. Okay, this is important, so please don't be doing this one on the calculator yet. We have to show all the algebra first. X equals negative b over 2a. So we think, well, what do they mean, a, b, and c? This is ax squared plus bx plus c. And that means we would want the negative of negative 3, which is 3, over 2 times 2, which is 4. So that means our vertex is at 3/4 something. Now, if we want the something, we have to take that 3/4 and we have to plug it back in to the original equation. And this I'm just going to quickly do up there on the TV so that we can see it. So we have 2 parentheses 3/4 squared minus 3 parentheses 3/4 minus 2. Math number 1, enter. It is negative 25/8 if we don't want to do it by hand. And I'm trying to get through everything we need to on this video, so that's the reason I didn't go through and do this one by hand with you. We will do some fraction by hand before we get out of here today. So 3/4 and negative 3.125. Now I can fix it. Oh, right there. But there's another way to do that too, using the calculator. So now I'm going to go back to, hey, how do we verify all of this with the graphing calculator? Well, let's find our y equals. And let's plug in our little 2x squared minus 3x minus 2. Now, the squared button that you want to use most of the time is right here to the left of the comma, because then you don't have to do that, hit the right arrow over to pop it out of the exponent position. So 2x squared minus 3x minus 2. Enter. And I really would like to see this in the negative 10 to 10 window, because that was what we had to graph on. So zoom 6. Looks beautiful. I want to double check that my zeros are right. So I do second trace, number 2. And now here's where things get a little weird, because this time there's 2 different intercepts that have to be approached differently because it's a parabola. Over here is the left side of that intersection, and here is the right side. But when we go to find the other one, they turn around backwards. For this one, this would be to the left of the intersection, and this would be to the right. So that takes some getting used to. That's usually one of the things that I have people emailing me about. I forgot again. How do you make sure you get each one of those? So I've got second trace already there. I'm going to move Blinky to the left of this intersection using the left arrow. Anywhere up there is fine. Blinky's fine wherever. Enter. And then my right arrow. Blinky doesn't know up and down. Blinky has a limited language. He only knows left and right. Enter. And then hit enter through guess. That is not a shocker. Negative 1/2 0. We knew that was happening. Second trace. Now I go after the other one, and I have to go backwards. Oh, well, that didn't give me what I wanted. Second quit. Let's try that again. Second trace. Number 2. So now I have to be below it to be to the left of it this time. It's all backwards. Enter. And I have to be above it to be to the right. Enter. And Blinky says, there it is, at 2, 0. Again, which we already knew because we did this algebraically. So now, let's say I forget that little formula to find the vertex. X equals negative b over 2a. Turns out, Blinky can do that anyway. So, I started thinking, let's see, this would be the lowest point for the vertex. Hey, I think there was something up there before about minimum. Second trace. Well, sure enough, there it is, number 3, the minimum. Now, Blinky wants to know, am I on the left of this little valley? No, you're not, Blinky. You got to come over here. Somewhere over here is to the left of that valley, and then I hit enter. And then I use my right arrow to go somewhere to the right, enter. And I don't want to take a guess, so I hit enter. Now, you're going to look at that and say, Cedarholm, that is not perfect 3/4. Oh, but Blinky did so well, because Blinky has to do calculus when we hit that button. So that is super close. And it might not be perfect, but if you look at this, think about how many positions we're talking about here. That 1/5 in the back, that's not making a lot of difference mathematically anymore. So it's really close to our 3/4, negative 3.125. And we can use that whether or not it's a minimum or a maximum to find that vertex point. Now that part of it you can't do without calculus. So once we get past a quadratic, once we talk about cubics and quartics and all of that, we have to use Blinky to find the minimum and maximum until you get through calculus in a year. And then you'll know how to do that. All right, so there's a lot more stuff we just did with our graphing calculator that can verify everything that we did algebraically. And the algebra went so fast. I mean, that's what you want to do. You want to use the algebra whenever possible. Now, we can solve graphically. If your equation is not set equal to 0, you can enter both sides of the equation as separate y equals equations and look for the intersection. Where do they hit each other? And I started thinking, well, that was up in that second trace button with Blinky too. Intersection was up there too. The calculator can do this. So this is another one where I know we haven't totally forgotten how to solve these, so we're going to do this algebraically first, but then we will see on the calculator that our answers work. Absolute value. When you have absolute value isolated, you have to remember that there are two solutions to this, and you need to put them according to the number line. So the negative one needs to be on the left, and the positive needs to be on the right. And then we add 1 to both sides, and divide by 2. Same thing over here. Add 1, and divide by 2. But now I want to start thinking about, what do I know about these things? And absolute value I know is a V shape. So I expect to see something with a V shape. And then it's supposed to equal 6. So 6 is going to go this way. And what I want to know is where those 2 points, where they hit each other. And that's negative 5 halves and 7 halves. That's what I should see. So if I punch it in wrong, I already kind of thinking about what it looks like, and I'll know. So now we go to the graphing calculator. And this problem totally hinges on, do we remember where to find absolute value? Which is, we don't use it a whole lot, so sometimes we forget. You might want to write down math, number, N-U-M, 1. Math, N-U-M, 1. That's what we have to do. Hit the math button, arrow to the right once to numbers, because absolute value is taken of numbers, and it says ABS. That's the one we need, ABS. Yeah. Oh, no, they're just out of order. Yeah, 5 should be the exact same one. That's weird, because it's always been in that first spot up there. Did you just buy that this year? Yeah, I know they're both there, but it's not in the right order. That's kind of weird. It's always been at the top. Doesn't matter. It's there. We won't. Oh, you have it in 2 spots. Oh, okay. It is different. Yes, yes. I didn't notice that you had it in complex numbers. Yeah, that's for the Mandelbrot set. Don't worry about that. We're not going to talk about fractals this year. So let's just stick with math, numbers, 1, and then you'll have the one you need. And we need, forgot while I was yakking, 2x minus 1. Enter. And we want to see when that's 6. Enter. Should work out really nice in our negative 10 to 10 window. We'll know in a second with Zoom 6. Oh yeah, we can see them. We can see those 2 solutions. And then we use Blinky to find them, see what they are. So second trace, number 5, intersection. Again, Blinky kind of leads us through. He says, is this the first curve? But here's the thing. Blinky's pretty far away from the point that we want to find out about. And usually that takes Blinky a little bit longer. So I'm going to help Blinky out and put Blinky a little bit closer to the intersection that I want. And hit enter. And notice Blinky pops to the horizontal line, which is what he's supposed to do. Enter, and enter through guess. Hey, 2.5. There's our 5 halves. Right there, negative 5 halves. One more time. Second trace, number 5. Getting Blinky closer over there so he knows which one I'm talking about. Enter, enter, enter. 3.5, 7 halves. Now in both of those you may have noticed it said y equals 6. Well, of course it did. That's what we put in for our second equation. The 6 wasn't what was mattering. What mattered was what x value are we talking about that's going to make this work. And we found that we were right. Now, like I said, this is backwards, and that's because this is the way the book approaches it. But we solved algebraically first, and then we verified graphically. And you probably want to take a second and just make just a quick little sketch of what it was that we saw when we graphed that. And we had the V, and we had the horizontal line, and we were looking for these 2 spots. Usually that's enough to bring it back to everybody. And oh yeah, now I remember. We were finding that intersection. So second trace is our go-to button for my pet Blinky. Once we have Blinky, away we go. All kinds of things we can do. And we just use the negative 10 to 10 window. They have the closer up, zoomed in version for us there. Starting to come back to you? Did you remember where absolute value was before we got there? Okay, a couple people did, because it's in kind of an out-of-the-way spot. Anybody need more time? Away we go! Notice when you're solving equations by finding the intersections, the value of y at the intersection point is irrelevant. We put the 6 in. We knew it was going to be 6. It had to be. The y was going to be 6. So the solution comes from the x value. That's what we're really trying to find. But there are times when it's going to be relevant. And this is one of them. Because we look at this and we say, okay, this is a v. This is a parabola. It's going from 0 to negative 4. That's its vertex. Oh, they want to know when those 2 things hit each other? I don't think I've learned that algebraically. You would be absolutely right. And we won't do them this year either. So we have to use the graphing calculator to find these. So one side, the left side can be y sub 1, the right side can be y sub 2. It doesn't matter which is which. But we want to know where do they hit each other. And like it says, this is where we start our, hey, everything's 3 decimal, rounded to 3 decimal places. Rounded to 3 decimal places. And I can see you're already starting, which is fantastic. So, we had absolute value, math, arrow to numbers, number 1, 0.5x plus 3. Pop it out of there, hit enter, and x squared minus 4. And I'm going to do my zoom 6 again. Now, if we couldn't see the intersections, then Blinky's not going to be able to find them for us, but we don't have to change the window on this one. We just need to find these 2 spots, which I'm going to ask you to do, please, and then I will go ahead and write down the solutions up here, and we'll make sure everybody is finding those intersections. take a peek up there when you're done. Anybody have anything different than that? Then we'll figure out what happened. Well, I know we had this very broad objective that said, you know, solve equations graphically, but we've just gone through tons, right? You feeling like you're okay with your graphing calculator at this point? Good. Because it's something we want to use to check. It's something we want to use to make some discoveries about. We need to remember why we're doing this. And like it says, these are all mathematical synonyms, which means they mean the same thing. Given a real number x equals a and a function f of x, if f of a equals 0, so you put your number in and you get a y value of 0, that means it's a solution. If the problem said solve, blah, 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 you found one of the solutions. It is also a root of the function. That language is not used as commonly. You know, usually we talk about the solutions. It is a 0 of the function. Yeah, that gets used a lot, that vocabulary of find the zeros. So we want to make sure when we're writing zeros that we say, hey, it's some number 0 to show that understanding of, hey, we're connecting this to the graph. X equals a is an x-intercept. More connection to the graph. And then, finally, A0 is an actual point on the graph, a point that we could use to very easily get our graph going and have what we need. So the math is the same behind all of these. Do the algebra first, grab a graphing calculator if you can't do it any other way. And that was the last one, the absolute value and the quadratic. So now, we move on to the good stuff. And this is, how do we solve this stuff algebraically? I mean, it's fantastic that we have a graphing calculator to check, but how do we solve it algebraically? We will focus on solving quadratic equations in this section. Already did the linears in the first part of chapter P. And a quadratic equation in x is one that can be written in the form ax squared plus bx plus c equals 0. In fact, that is called standard form for a quadratic, where a, b, and c are real numbers and a is not 0, because if a were 0, we'd have 0x squared, and then it would drop out and it would be linear. So something has to be in front of that x squared that's not a 0. Now, we have 4 ways. The first one, the fastest one, and you could argue the easiest one, would be to factor. Done that lots. Most people are really good at it. Then we have the one that it's kind of a weird name. It's called extracting square roots. But really, that's a precursor to one that we are really going to focus on here at the pre-calculus level, and that's called completing the square. And that's not because you're going to do a lot of completing the square in calculus. It's because of the algebraic steps and algorithm that it takes to get there. That method is really important to our thinking process, breaking a problem down. Now, if we have forgotten all 3 of those as a last resort, we have the quadratic formula. And really, in this level of math, that should be a last resort. Completing the square will solve any quadratic. So if we remember the steps to that, that's the way we should do it. But by the time you take the MCAs or the ACTs, some of you anyway, you might have forgotten the completing the square process. But the little tune, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It pops into your head, and you can find the answer. I mean, that's what matters when you're taking the ACTs and the MCAs. Can you figure out the answer? So to solve by factoring, we are really using the 0 factor property. And that says let a and b be real numbers. If you multiply 2 numbers together and you get 0, one of them had to be 0. Totally makes sense. It had to be. That's the only way that you're going to get that. So either A is 0 or B is 0. So in the black here, we see which is the correct solution to x times the quantity x plus 1 equals 0. And I say, they factored it for us. Wowzers. Well, this one, if it's 0, will create a 0. Because 0 times anything will give me 0. I just need to figure out when would x plus 1 equal 0. And that doesn't take too long either. Most of you probably just looked right up there and said, well, negative 1 plus 1 would give me 0. So this one has two solutions. Because it's a quadratic, it has two solutions. Quadratics can have no solutions, one solution, or two solutions. And there they are. There's our zeros. 0 and negative 1. So if we can factor it, oh yeah, that's what we're going to do. We're going to factor it. Which, in the blue it says, look back at example 1a and resolve it by factoring to get the same solution. We already did that. I had you do that already. And we verified with the graphing calculator. Oh yeah, we see it. We may see it as a decimal on the graphing calculator, but it's the right answer, which is fantastic. We've verified that what we've done is correct. To solve by extracting square roots, you must be able to write the equation in the form a binomial squared equals a constant. This is actually a precursor to the process of completing the square. And remember, when we physically write down a square root symbol to solve, we have to put a plus or minus in there. So don't think about that whole principal root business that we were talking about in the earlier prerequisite sections. If we are solving and we physically write a square root symbol down, we have to put plus or minus. There are two roots. So this says solving by extracting square roots. Again, kind of a crazy name. But you start thinking about, well, how would one extract by taking a square root? You'd have to have something squared, because the inverse of something squared is taking the square root. And that's what's happening here. I don't want to get it into my head, oh, I better write out 2x minus 1 times 2x minus 1 and do FOIL, and right away you see you're complicating this problem. All I have to do to get rid of something squared is take the square root. But as I physically write that square root symbol down, I remember, ooh, but that's going to be a plus or a minus. So that means I'm going to have two setups for this problem. It's 2x minus 1 equals negative 3, and 2x minus 1 equals positive 3. And go ahead and solve those. No, we're not going to. But we could put the left side in our calculator as y sub 1, the right side in as y sub 2, and make sure they hit each other at those spots. But the algebra here, it more than supports what we did. So now I look at B, and I'm thinking to myself, I really liked what I did in A. I wonder if I could make B look like that. It's a key concept in math. By just doing one or two things, can you get this to look like something you already know how to do? And I think, wait a second, this might be a perfect square trinomial. Because this is 3x squared, and this is 5 squared. Okay, wait, but you always have to check the middle term. So to check the middle term, I'd take 3x times 5 and multiply it by 2, and I'd see, does it equal 30? 3x times 5 is 15x times 2. Well, look at that. It's a perfect square trinomial. Now that's really important, because perfect square trinomials can be written as a binomial squared. And I realize, well, I have to put the 3x in front, because it was 3x squared that gave me 9x squared. And then I have to put a 5 in the back, and because it's all pluses over there, this is going to be a plus. So you have to check the sign between the first and second term. Figure out what to put there. Well, now that's just like this other problem over here in A. That's exactly what we wanted to happen. So we square rooty toot toot. making sure to put the plus or minus. And then again, we have our two setups, and we solve. Always putting the negative one on the left and the positive one on the right so that it lines up with the number line. And again, go ahead and solve. I seriously doubt you need my help with this. Everybody good? Negative 11/3 and 1/3. We could check that on the graphing calculator too. You know, we just have to figure out in our head 11/3 and go after it there. Now, like I said, this extracting square roots is really a precursor to completing the square, what we just did. So the technique of example 2 is more general than you might think because every quadratic equation can be written in the form a binomial squared equals c. The procedure we need to accomplish this is called completing the square. So to solve x squared plus bx equals c by completing the square, add b over 2 squared to both sides of the equation and factor the left side of the new equation. And this looks a little scary, but here are the two things we need to remember. There's one glitch with completing the square, and that is to complete the square, you must have a 1 in front of the x squared term. If it's not, you have to divide everything by whatever's in front of that x squared. So you divide by a. And then you have to remember this b over 2 squared formula. Now, I don't believe in memorizing, but this is one of those things most people do just memorize. But I want to show you where it came from, because that's more important, that you have a deep understanding of where the math came from. So, I think back to what I just talked you through when we did this b problem. Remember I said I've got to think, what did I square to get 9x squared and 25? So to undo that, we took square roots. And then to check this out, I had to multiply them together and multiply them by 2 to see the middle term. Well, to undo that, I'd have to divide by 2. So really, it's just the process backwards. I divide by 2 to work my way out to these, and then I square them to get back. That's all it is. It's the inverse of the procedure. So b over 2 squared, even if you forgot it for a second, you can kind of reason your way through it and see how it works. To solve ax squared plus bx plus c equals 0 by completing the square, yep, here's the big one. If that a is not a 1, we have to divide by it. Has to be a 1 to complete the square, for completing the square to work. So example 3 says, let's get to it. Let's solve by completing the square. Solve 4x squared minus 20x plus 17 equals 0 by that process of completing the square. And the first thing I see is, oh, there's a 4 out front. Well, that's how we begin. Let's divide everything by 4. And that does what it usually does. It creates fractions. But fractions are our friends. We'll be fine. It's not a problem. So now I think, I wonder if this isn't a perfect square trinomial already. Let's see, this is a perfect square. Oh my goodness, no. 17/4 is not a perfect square. So if it's not a perfect square, it can't stay there, because I have to put in a number that is. So I'm going to move it out of the way by subtracting it. Because what I have to do is find the number that will make that a perfect square trinomial. And notice I put 2 boxes on there because whatever I do to one side, I have to do to the other. I don't want to forget, hey, this has to happen to both sides. All right, the little formula. B over 2 squared. Okay, and this is ax squared plus bx plus c, so here it is. B is negative 5. Now, when you have parentheses being raised to a power, if it's pure multiplication or pure division, so no addition or subtraction, then you can just distribute that power. So this is really the same thing as negative 5 squared, the whole thing squared, over 2 squared. Made a little dot there. So that'll be 25 fourths. That's the number that's going to complete the square. So that's the number that I have to add to both sides of this equation, which is perfectly legal in math. That's one of our properties. Addition property of equality. Now I have made this on the left-hand side a perfect square trinomial, which means I'm going to be able to write it as a binomial squared. And over on the right-hand side, we got lucky, and they even have a common denominator. So negative 17 plus 25 would be negative 8 fourths, which would be, or not negative. I think I said it backwards. Oh, how can I write this on here so that somebody that's not here will look at this and say, I know what they were doing. There, I'll do that, and then I'll just make this a 2. There. Now it looks exactly like the problems we just got done doing. If we can fill in what it is that had to be squared. Well, pretty obviously, this is going to have to be x. And then I think to myself, wait a second. Didn't I already find out what had to be squared? Yeah, because I squared it over here. It was negative 5 halves that I had to square to get that. So I don't have to do any new math for this. I just have to look back and see, what did I square to make this happen? And now we do exactly what we did on the last page. We take the square root of both sides. Make sure we put the plus or minus. And then we add 5 halves. And we get a perfect answer of 5 halves plus or minus the square root of 2. Now, we absolutely could check this on the graphing calculator, but if we were going to do that, we would need to know what this is as a decimal. So I'm just going to do this one on the TV up there. So 5 divided by 2 parentheses plus, oh, I should do the minus one first, minus second square root of 2. So there's the first one, 1.086. And for the second one, I'm going to cheat because I don't like doing all that typing. Second, enter, and I'm going to go back and just change this to a plus. 3.914. An efficient use of time rather than punching the whole thing in back in again. So second enter will plot that up there. Now we could check it with the graphing calculator and make sure that this was actually correct. Well, we have one more, and this one looks like a monster. Wow, look at that. All right, away we go. Well, too much gunk, and there's a set of parentheses. This definitely needs some simplifying to make it look like the stuff that we were just doing. So, this side is fine, except my 2 just went crazy there. But it's x squared plus 3x, and then I have to be careful and distribute the negative. So minus x squared minus x plus 3. Better combine some like terms on that right-hand side. Rats. All right, so we need to combine like terms on the right-hand side. The x squareds will drop out, and we have 2x plus 3. Now let's move that over to the other side. And we realize now we have to divide by 3 because we can't have anything but a 1 in the front. So with completing the square, we know that 10/3, negative 10/3 is not going to work. We're going to go ahead and add 10/3 to both sides. And now we get to the interesting part where we have to find b divided by 2 and square it so that we'll know what to add to both sides. So in this case, we have a fraction for b, and we have to divide that by 2 and square it. But you don't divide fractions, you multiply by the reciprocal. So we're going to have to take negative 8/3 times 1/2 and then square it. We can do a little reducing, and we will get negative 4/3 squared, which would be negative 4 squared, which is 16, and 3 squared, which is 9. So to complete the square, we need to add 16/9 to both sides. That will make a perfect square trinomial. And on the other side, we'd have to do our little common denominator of 9. So we'd have 30/3 plus 16/3, which is 46, or not thirds, ninths, 46/9. And then back here, we just remember what did we square to get this. And that's right over here, negative 4/3. Now we can take the square root of both sides. And the square root of 46 is not going to be nice, but the square root of 9 is. And that's great because then our denominator does not have a radical in it. Let's add 4/3 to both sides. And we get 2 brilliant, perfect answers. We have 4/3 plus the square root of 46 over 3. 4/3 plus the square root of 46 over 3, and 4/3 minus the square root of 46 over 3. And so tomorrow you will watch day 2. You need to use the completing the square worksheet that was included in the pile of good stuff you got on the first day of class.